Hello students, and welcome back to another algebra video. You know what to do. Pause the video, try these problems in your notes, and when you're done, unpause it, try them with me. You'll notice that this says in example 2. This is, remember, the first problem that we do is always a little review from the previous video. So when they say in example 2, they're talking about the last example we did in the last video. But you actually don't even need that to do this problem. We can just have let f of t be the outside temperature t hours after 9 a.m. Explain the meaning of each statement. So this is basically the same as the last problem from the previous video, but now we're after 9 a.m. instead of after 6 a.m. So what does f of 4 equals 75 mean? Well, 4 is our input. That means we're talking 4 hours after 9 a.m. So 4 hours after 9 a.m. is 10, 11, 12, is 1 p.m. So at 1 p.m., it's 75 degrees outside. That's what f of 4 equals 75 means. At 1 p.m. it is 75 degrees outside. All right, f of m equals 70 degrees. This means m is our input, so we're talking m hours after 9 a.m. So m hours after 9 a.m. it is 70 degrees outside. Now, we don't know exactly how many hours. Some number of hours, m. Okay. And part C says f of 2 is equal to f of 9. F of 2 means that we're talking the temperature 2 hours after 9 a.m. So 9, 10, 11. The temperature at 11 a.m. is the same. That's what equal means. Equal means is the same as the temperature at, what is 9 hours after 9 a.m.? 10, 11, 12. 1, 2, 3, 4, 5, 6, 7. Wait, 6. 6 p.m. At 6 p.m. Temperature at 11 a.m. is the same as the temperature at 6 p.m. Okay, and lastly, part D. F of 6 is greater than f of 0. So, we could say it's hotter, because, right, if the temperature is larger, that means that it's hotter. It's hotter at, what is 6 hours after 9 a.m. is, what, 3? 3 o'clock? 11, 12, 1, 11, 10 a.m., 11 a.m., 12 a.m., 1 p.m., 2 p.m., 3 p.m. Yes, it's hotter at 3 p.m. than at 9 a.m. Because if we're 0 hours after 9 a.m., we're at 9 a.m. Okay, and that makes sense. It makes sense that it would be hotter at 3 p.m. than it would be in the morning. In the morning, the sun hasn't quite come out yet. Okay, there you go. That is a nice little review from yesterday. Now, let's move on to what we have for today. So, we are continuing 3.3 in this video, and our learning target in this lesson is, I know how function notation is used. And the success criteria is I can use function notation to solve and graph functions. So yesterday we evaluated and interpreted functions using function notation. Today we are solving and graphing. So first, a little review of what function notation is. remember we replace y with f of x. That's how we say it out loud. F of x. And what that means is when the input is x, what is the output, or the value of the output? The value of f at x. Okay. So, we're going to do example 4 and then example 3. I know it seems a little weird to go out of order, but I think it's going to be better this way. So, graphing a linear function in function notation. So, here's what we're going to do. We're going to take a table of inputs, or x values, and outputs, y values. And we're going to make a table. So, we get to pick whatever numbers we want. So, let's see, 0, 1, 2, 3. Let's just pick some easy numbers. And let's do a negative number too, though. Let's do -1, 0, 1, 2, 3. Sure. And what we're going to do is we're going to say, if -1 is my input, then what is my output? So we're going to evaluate f at -1. If the input is -1, what is my output? Well, my output is 2 times -1 plus 5. 2 times -1 is -2 plus 5, and -2 plus 5 is 3. So, when the input is -1, the output is 3. And we're going to continue filling in this table. I'm going to show you why we're making this table in the end when we make our graph. So the table is important for the graph, but first let's fill in the table. Okay, so now what about when the input is 0? Then what is the output? What should go on this side of my table? Well, we have 2 times 0 plus 5. 2 times 0 is 0. 0 plus 5 is 5. So when the input is 0, the output is 5. Okay, let's continue doing this. The input is 1. So I have 2 times 1 plus 5, which is 2 plus 5, that's 7. So when the input is 1, the output is 7. Okay, and I think we might only have room to do 2, actually. We might not have room for 3, but that's okay. You know from all of these how to do f of 3 if you really want to. So, f of 2 is 2 times 2 plus 5. Remember, we're just replacing x with whatever is inside of our parentheses. So 2 times 2 is 4 plus 5. 4 plus 5 is 9. So when our input is 2, our output is 9. Okay, if you want to, try f of 3 on your own and see when the input is 3, what is my output? You can try that yourself. Now, what we're going to do is, what do? I found all of these inputs and outputs, but why? Well, remember, the inputs and outputs can be turned into points. So this set of inputs and outputs, and actually let me get a different color. This set of inputs and outputs becomes the point -1, 3. And I can put that point on my graph. That's why we made this table, is so I can take all of these sets of numbers, input, comma, output, and put it on my graph. So, -1, 3, 0, 5, 1, 7, and 2, 9. I remember those came from these sets right here. This makes the point -1, 3. This makes the point 0, 5. This makes the point 1, 7. And this makes the point 2, 9. And I'll label them on our graph right here as well. Okay, now what? We just connect the dots. We know that this is a linear function. We know that we are graphing a linear function. So, all that is left to do is to connect the dots. That was not very pretty. Let me try that again. That was a little better, maybe. Okay, so, yeah, connect the dots, and there you have it. We've graphed it. You'll notice that I only need 2 points, right? 2 points makes a line just fine. So you don't need to make a table with 4 inputs. You can just pick 2 if you want to. But the more you do, the more of like a check you can have. Whoops, I dropped my pen. The more you can check, right? Because if this point had been, if you had accidentally put it here, you would know, well, wait a minute. All the other points are on this line, but this one's out here. Does it do that? Like, no. So the more points you do, the better of a check you have when you actually go to graph your line. Okay? Cool. Yeah. And if we had done f of 3, we would have put it on the graph as well. It would have been 11 is what you should have gotten if you tried. We would have 3, 11 if you tried it. Okay, all right, let's check and make sure that we were correct. Make an input-output table to find the ordered pairs. So this table gives us our ordered pairs. Now notice that they did their table sideways. We did ours up and down. I think it's easier to see input goes to the output if you do your table like vertically. They did their table horizontally. It doesn't matter which way you do it. Do whatever way you feel comfortable with. And then they used different numbers than we did. It doesn't matter because our graph looks exactly the same as theirs. So it doesn't matter. If your friend picks these numbers to graph and you pick these numbers to graph, it doesn't matter. It doesn't matter. Use whichever ones you are comfortable with. Okay. And yeah, our graph looks exactly the same. So we were right. Yay. Okay. Now we're going to move on to example 3. And the reason I wanted to do this in different orders is because we know how to take an input and find an output. We learned that in the last video. If x is equal to -1, then find f of x. In example 3, what we're going to do is I'm telling you h of x equals -7. What is x? What do we need x to be in order for h of x to equal 7? And the reason I wanted to do example 4 first was because you can see more easily what they're asking you. So they are giving us the output. They're giving us the y, and we want to find the x. So instead of saying, here's -1, find 3, they're saying, here is 3, find -1. So we're going backwards this time. So let me show you how we do this. We have h of x equals 2/3 x minus 7. Oh, excuse me, minus 5. We also know that h of x equals -7. Well, h of x equals 2/3 x minus 5, h of x equals -7. H of x is equal to both of these things. So what we're going to do is we're going to say 2/3 x minus 5 equals -7. Because both of these things, the 2/3 x minus 5 and the -7, both of them are equal to h of x. And if both of them are equal to h of x, then they must be equal to each other. It's like saying x equals 2 and y equals 2. Well, then x equals y, right? We can say that because they're both equal to 2. We're doing the same thing here. They're both equal to h of x. So we're setting them equal to each other. Okay, back we go. All right, and now look at this. Now that I have this, hey, I can solve for x, just like we did in chapter 1. Okay, so first thing I need to do, let me zoom in here. Let's get our game face on. Okay, I want to get x by itself. So the first thing I'm going to do is I'm going to get this 5 out of here. And the way that I do that is I do the opposite. So the opposite of -5 is +5, and they go away. Now I have 2/3 x equals -2. Okay, now there are two different ways that I can move on from here. One is, how do I get rid of a fraction? Well, you can multiply by the reciprocal. And what the reciprocal is we take 2/3 and we flip it. The reciprocal of a fraction is flipping that fraction. Top becomes the bottom, bottom becomes the top, and just flip it. So if we multiply both sides by 3/2, look, we have ×3 divided by 3. So they cancel out. If I have a 3 in the numerator and a 3 in the denominator, that's just 1, and they go away. And look, I also have a 2 in the numerator and a 2 in the denominator. And that also equals 1. Whoops, equals 1. So they go away. And then I can multiply. I have -2 times 3 is -6 over 2, and -6 divided by 2 is -3. That's one way to do it. If you're like, recipro, what? I don't know what you're talking about. There's another way that we can do this. And that is, we can do it this way, but if you don't want to, ignore that. What we can do is we can say, I have a 3 in the denominator. That's like dividing by 3. What's the opposite of dividing by 3? Multiplying by 3. So let's multiply on 3, or multiply by 3 on both sides. That gets rid of the 3 in the bottom. And I have 2x equals -6. Okay, how do I get rid of the 2? Oh, we remember that. Just divide by 2 on both sides. And x equals -3. Oh, wow! So we get the same answer, no matter which way we do it. If you liked the reciprocal, it kind of saves you a step, a little bit. You're still multiplying by 3 and dividing by 2, but you do it like all at once. So if you like the reciprocal, go for it. And if you do not like the reciprocal, that's okay. You can do it this way as well. Okay, so what this means is h of -3 equals -7. So when x is -3, then h of x equals -7. And the short way of saying when x equals -3, then h of x equals -7, the short way of saying that is h of -3 equals -7. So now what we just did is I gave you h of x and you found x. So it's kind of the opposite of what we did in example 1 in the last video and in example 4 of this video. Okay, let's check and make sure that we were right. When x equals 3, h of x equals -7. And remember, the short way of writing that is h of -3 equals -7. And we were right. Woo-hoo-hoo-hoo. And of course, they have their steps right here for you. Okay, wonderful. So that is all I have for you in this video. What I'd like you to do right now is rate yourself on a scale of 1 to 3. Where are you at with our learning target and our success criteria? Do you have a lot of questions? Are you very confused? That's okay. That's totally okay. I was here for all of college. I had to talk to my teachers every day to make sure I was understanding what was going on. And if you do too, that's okay. We're in the same boat. All right. And if you're a 2, work on the homework. That'll help you practice. If you're a 3, check in with your friends. See if they need any help. Okay. All right. Assess your understanding. Now, here are some practice problems that you can do to practice the skills that we have learned in this video. Remember, always do the homework that your teacher assigns, but these match with the examples that we did in class. Ooh, excuse me. These match with the examples that we have done in this video. All right, and as always, let's end our video with a launch, shall we? Today's launch comes from Martin Luther King Jr., and he says, "If I cannot do great things, I can do small things in a great way." And I love this quote because some of us, we're not destined to do great things, big, grand things like maybe solving world hunger or finding a cure for cancer. Not all of us can do that. So we might not be able to do big, great, grand things, but all of us can do small things in a great way. We can smile at people as we walk down the hall, when we can walk down the hall. We can text our friend when we know that they've had a bad day. We can bring food to somebody that we know does not have as much as we do. And we can volunteer at food banks. There's so much that we can do. So much. Even just asking somebody, "How are you doing today?" Like, really, how are you doing? Not just, "Oh, hi, how are you?" "Oh, I'm good." Like, no, really, how are you doing? Listening to your friends. Listening to a stranger. Small things. We're all capable of doing small things. And we can do them in a great way. So, what are some small things that you can do in a great way today? What are some things that you can do to help your parents or your siblings or your friends, the people that you care about? Think of ways that you can bless them, small things that you can do in a great way to help the people that you love. So, that is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day, and thanks for being here. Thanks for watching. Bye!